Have you ever wondered how a machine learns? What is the difference between a model that runs with answers and a model that runs without any answer at all? This fundamental difference defines two major paradigms in learning: supervised learning and unsupervised learning. In this video, I will explain how these two paradigms work using two proper algorithms, such as random forest and k-means clustering. And after understanding the concept, we will apply them to a real dataset to see how they behave in practice. Okay, welcome to my channel. My name is Gifari, and I'm currently a bachelor's degree student in electrical engineering at University of Brawijaya. Machine learning is widely used for classification, prediction, and pattern discovery. But before we can choose an algorithm, we need to understand a key question. Do we have reliable data? If the answer is yes, we can use supervised learning. And if the answer is no, we must rely on unsupervised learning. Let's start with supervised learning. So, what is supervised learning? In supervised learning, we train a model using input data X and corresponding target values Y. The goal is to learn a function f of X is equal to Y. This means the model learns the mapping from input filter to known outputs. Typically, tasks include classification and reducing. And one powerful supervised algorithm is random forest. Random forest is an ensemble learning method based on decision trees. First, let's recall what a decision tree does. A decision tree splits data step by step based on filter values until it reaches a final decision. However, a single decision tree has a weakness. It tends to overfit. Random forest solve this problem by breaking many decision trees that each tree is trained on a random subset of the data is called bootstrapping. Use and each tree use a random subset of filter at each step. Finally, all trees work. The majority work become the final prediction. This randomness makes the model more robust. Instead of relying on one potentially unstable tree, we average many trees, which reduce variance and improve generalization. Some important parameters in random forest include an estimator, which is the number of trees, next step, which is how deep each tree can go, and mean sample squared, which is minimum samples required to spread. Increasing the number of trees generally improves stability, but also increase the computation time. Then, what is unsupervised learning? Unlike supervised learning, unsupervised learning does not use reliable outputs. The model only sees input data and tries to discover hidden structure. One common unsupervised task is clustering, and in this video, I use k-means clustering algorithm. K-means is one of the most popular clustering algorithms. Its goal is to partition data into k-cluster such that points within the same cluster are as similar as possible. But what does that mean mathematically? Now, let's format k-means mathematically. Suppose we have a dataset X in a generic D-dimensional space and we initialize k cycles, meaning we want to form k cluster. We will discuss later how to choose the value of k, but for now, assume it is different. Think of both the data points and the cycle as vectors in D-dimensional space. The first step is the assign step. For each data point, we calculate its distance to every cycle. Instead of just taking the raw distance, we actually square it. This is done purely for mathematical convenience, since squaring does not change with cycle process, but it makes the math simpler to work with. After computing the squared distance to allocation points, we pick the smallest one and assign that data point to the corresponding cluster. This assignment is represented using Ci, which indicates the cluster to which the I at data points belongs to, and once the points are assigned to the cluster, the next step is to update the same codes for each cluster We check are the data points starting to act and conflict their main position. That after become the nerve central for the next lesson. What we are actually doing in K-means is minimizing the cost function usually denoted as G. This function measures how far each data point is from its assigned sample. Mathematically, it is written with a global summation. The English summation represents the assignment of data points to a particular cluster. The outer summation means we are doing this for all K cluster. This function is stored within cluster sum of squares. In simple terms, the algorithm is trying to move the circle in such a way that this cost always decreases with every iteration of k-means, and it will never increase. Now, the question is how do we decide how many clusters we actually need? For example, if we set k is equals to 2, the data splits into two clusters. If we set k is equals to 3, the splits further. And for higher values of k, the cluster kept getting divided into smaller groups. One of the most widely used approaches to find the root value of k is the elbow method. In this method, we run k-means for multiple values of k, and for each case, we calculate the cost function g, then we plot the value of k against the cost. Now we don't simply pick the k where the cost is the smallest because the cost always decreases as k increases. Instead, we look for the elbow points on the graph after which the cost is no longer reduced significantly, and the improvement becomes marginal. In this example, k is equals to 3 looks like a good choice. So, k is equals to 4 here is also acceptable. Now, we should not really on these mathematical methods to decide the optimal values of k. Choice of cluster also depends on the actual application. Now that we understand the concept, let's apply this algorithm to array dataset to see how they perform in practice. Now that we understand the concept, let's apply this algorithm to array dataset to see how they perform in practice. For demonstration, I have simple project. The dataset I am using comes from the test Western Reserve University Training Data Center, which is one of the most widely used benchmark dataset in the field of the technical fault diagnosis. So, this dataset contains vibration signals recorded under different varying conditions, such as normal condition in rush fault, occur rush fault at 3 o'clock, 6 o'clock, and 12 o'clock. And then there is var fault. The goal is to classify this condition based on vibration characteristics. In this case, I'm using a dataset for the graph and vision. So the project I made tests many machine learning algorithms, but in this video, we only focus on k-means clustering and random forest classifier. So, first, so far, we import the required libraries first, especially such as NumPy, Pandas, Scikit-learn, XGBoost, Matplotlib, C1, etc. Now, the raw data is just vibration. Yeah. This is the raw data. The raw data is just a time series vibration signal, a long sequence of numbers. We can quick get directly into most machine learning algorithms. So the first step is the filter extraction. Yeah. So we extract 21 filters from each vibration signal and divided into two categories. First, the time series time domain filters. Yeah. Time domain filters, and then frequency domain filters. The time domain filter includes mean, standard deviation, variance, RMS, Skewness, Kurtosis, peer-to-peer, track record, sub-record, etc. And so for the frequency domain filter, filter. It includes like frequency mean, standard deviation, the band energy filters, etc. Before training model, you need to pre-process the data. In this pre-processing data, there is three steps. Step one is standardization. So we apply standard standard which stem from each filter to have a mean of 0 and a standard deviation of 1. Then the step 2 we can just split the data. So we split the data into 80% training and 20% core testing that gives us the 2,560 training sample and 640 test sample. We use that stratified splitting to answer each form as is proportionally the question in both sets. And then the step 3 is the PCR. PCR is a dimensionality reduction technique. So we originally have 21 filters. And PCR help us understand how much information each direction and the data carries. So we focus to the KMeans. And then this is the KMeans clustering. Yeah. So to apply KMeans in Python, I use the scikit-learn library. First, we initialize the model using the KMeans traces, right? Then see here there's the documentation. Then we put the model to the filter data. Yes, we put the model into using the filter data. And predict the cluster data. So we use the fit predict method. Yes. So we fit first and then we predict the cluster data. Then the cluster data is set in this variable. And then to visualize the cluster result, I figure the filter space to dimension using PCA. Yeah. Then we visualize the result. And this is the result. Now let me show you that she happening behind the scene. So if we look at the cited in source code on the GitHub, we can see the accurate quick and paste method here. Then you can see the result of the KMeans clustering. Here it is. So the clustering partially supplies the data, but it does not perfectly match the true fault radar. When we force k is equal to 6 to match the actual number of workers, we got a CWRU score of about 0.59 yet. And a low adjusted band index. So we got the low RRI and IMI. The clustering result didn't align well with the two radars. So what you can score compare? Here is three key reasons. First, gaming has no access to radar, so it closely based on the scan in the critical space. Second, some focus, particularly like OR3 and ER in the rest part, have very similar vibration patterns and overlap in their filter space. Third, scanning assumes greater cluster of similar size, which doesn't match the actual data distribution. And then we go to the random forest supervised. So for supervised learning, I use random forest. First, the dataset was split into sync and test. Then the model was defined. Here's the model. So random forest classifier with 100 keys. Then after training, we fit the model. Yeah, we fit the model. And then the position will make on the test set. Then we check in the underscore RF. The model achieve high classification accuracy. The model achieve the high classification accuracy. So let's take a peek at the source code of random forest to understand what is really happening inside Frederick. Yeah. And then one advantage of random forest is that it provides greater importance. Yeah? So we observe that standard deviation and variance and shape vector is the most important features. So this conclusion highlights the difference between the two paradigms. Unsupervised learning, such as K-means, is tackling natural groupings without radar. And then supervised learning, such as random forest, use nearby data to learn precise decision boundaries. When nearby data is available, supervised learning typically achieves high classification accuracy. You can see in the result of the model. Okay. In conclusion, understanding both supervised and unsupervised learning is fundamental in machine learning. Unsupervised methods help us acquire structure in data, while supervised methods provides competitive performance when labels are available. Thanks for watching. See you again.